Good morning, class. Today we are going to continue working on the concepts that we have been building on perimeter and area. So just to give you a look ahead, next week we're going to be using this map. This is an actual map of our school to find the area and perimeter of different parts of our own campus. Before we can do that, though, there's one last lesson that we have to do on the basics of area and perimeter, and that is on the concept that area is additive. So the instructions here say to show how to break the rectangles up into two smaller rectangles. Show two different ways. I'm going to ask that you already have this sheet printed out and that you follow along with me as we go through this part of the sheet together. Okay. If you don't have the sheet, go ahead and take a moment and pause now so that you can find it and print it out. When you're ready, we're going to go ahead and get started. So there are two different ways that I can break these apart to find the area. So far, when we've been solving for the area, we've only been looking at a square or a rectangle, but here we have two irregular shapes. However, I can apply what I know about squares and rectangles in order to find the area of these shapes. So one way that I could break this into two rectangles would be to use my ruler and continue my line all the way down. So I'm going to do that. Okay, so now I have a smaller rectangle and then I have my bigger rectangle up here. And just for the sake of ease, we're going to call the big guy A, and we're going to call the littler one B. So if I'm solving for the area of A, I would say that A is equal to, and what's the formula for area? That's right, length times width. So I would say A is equal to length times width. Now I can substitute in my values. So A is equal to what? That's right, the length is going to be 5 feet times the width. And here we have to do a little bit of addition. So we know that the width of this portion is 4 feet. I can find the width of the entire side of my rectangle by adding this length here. Can you see that this length, 2 feet, is the same as this length? So this is also 2 feet. So by adding these two together, so I have 4 plus 2, what do I get? I get 6 feet. So my width for rectangle A is 6 feet. So then my final area for rectangle A is going to equal 5 feet times 6 feet. So what will that be? It'll be 30 feet squared. All right, but we're not done. So we know this area here, but we still need to solve for the area of B. So let's do that by writing out B is equal to, what's the formula again? That's right, length times width. Now let's substitute in those values. B is equal to, well, we already know the length for this little rectangle. It's just 3 feet. So let's say 3 feet. And we also already know the width for this little guy, and it is 2 feet. So now we have B is equal to 3 feet times 2 feet. So what is B equal to? It's equal to 6 feet squared. All right, now this asked us not to just find the area of each individual rectangle, but to find the entire area of the shape. So now that we know the area of each individual rectangle, we still have one more step, and that is to add A to B. So I need to add A plus B. So that means I need to add, so I would take A plus B, which would be 30 feet squared plus 6 feet squared. So the area of my total shape, A plus B, is going to be what? 36 feet squared. Okay. Now look at this shape. It's the same as this one and the measures are all the same, but is there another way that we could have broken apart our rectangles or drawn our rectangles to solve for the area? Pause for a moment and see if you can find another way to break this into two rectangles. All right. I'm going to go ahead and use my ruler, and this time, instead of continuing this line, I'm going to go in the other direction. And I'm going to match up to this line here, and I'm going to draw a line going all the way across. Perfect. Now, just like we knew before that this line here that was 2 feet was equal to the opposite side of this rectangle, we can do the same thing here. We know that this is 5 feet, so this line here must also be 5 feet. So if I want to solve for the total length of this longer rectangle, I need to add together 5 feet plus 3 feet. And what do I get when I add those two together? I get 8 feet. Great. Okay, now we have everything that we need to be able to solve for the area of this shape. So just like we did before, we're going to call the bigger rectangle, or the one with the most area, A. And then we're going to call the little guy B. Okay, and we can go ahead and write this out. So we have the area of A, which is equal to what? Length times width. Let's substitute in those values. What are the values for length and width for rectangle A? In this case, it's going to be 5 feet times 4 feet. So what's the final value for the area of A? 20 feet squared. Now let's look at rectangle B. What's the formula for finding the area of rectangle B? Just like A, length times width. Now let's substitute in the values. What are the values for length and width? 8 feet times 2 feet. So what's the final value? That's right, 16 feet squared. Now I found the value of rectangle A, and I found the value of rectangle B. Am I done if I'm trying to find the value of the entire area of this shape? No. What do I need to do next? That's right, I need to add my areas together. So A plus B, or 20 feet squared, plus 16 feet squared. And that will equal 36 feet squared. So even though we broke the rectangles apart in a different way, we still got the same area each time we solved. Okay. Now the next question says, Charlie and Frank want to determine the area of this rectangle. So before we move on to the next section, let's just count what the dimensions would be for the width and the length of this rectangle. Go ahead in your head and see if you can find the width of this rectangle. Did you get 7 centimeters? Now let's count the length. Did you get 8 centimeters? Great. Now let's move on to the next question. It says, Charlie found the rectangle's area using the following equation. 8 times 7 equals A. Frank found the area by adding the products of the following equations. 2 times 7 equals A, and 5 times 7 equals B. Whose equations will find the correct area of the rectangle? Explain. So to begin your lesson today, I want you to take a moment and consider each of these equations and decide which of these equations you would use to find the area of this rectangle and explain why here. When you've finished, you'll move on to your second sheet for today. Your second sheet looks like this. So we're looking at more additive shapes. So just like we did in the 2 example problems, you will go through each of these 6 shapes and you will find the area by breaking them into recognizable rectangles. Good luck!